Good morning, children. Welcome back once again to my maths class. In today's video session, we are going to talk about the exercise problems dealing the logarithms. In the previous session, we have studied the logarithms, the definition of logarithms and the properties. Okay, let's have a quick recap of the yesterday's previous session of logarithms. Okay, yesterday we have learned about the definition of logarithms. If a to the power of x is n, log n base a is x. This is the definition of logarithm. Also, we have gone through the laws or the properties of logarithms. These properties, we are going to use them in the exercise problems. Okay. The rule 1, log a base x. This is called as the power rule, where the power is being brought to the other side. Okay. Then, same wise, if you have a power in the base, the power will become the denominator. The rule 2 is the rule of multiplication. If it is multiplied, the number, then it will be separated as addition. Then rule 3 is, if the number is in the division, then the number will be separated to difference. Okay, it is separated to the difference, like log x minus log y. These are the properties. Also, we have learned that log 1 is, the value of log 1 is 0 and log a to the base a, like this also we have revised. Log a base a is always 1. Now, let's start the exercise. Okay, determine the value of the following. So, I have noted down all the problems, all the bits here. Now, let's solve. Now, the first one is log 5 to the base 25. Here, we will be applying the rule of power. When, see here, log 5, 25 can be written as 5 square. Okay, in the rule of power, if in the base there is an exponent, that exponent will come to the denominator. That means 1 by 2 log 5 base 5. So, what is log a base a? Equal to 1. So, 1 by 2 into 1 comes up to 1 by 2. Here, you can also write, if it is a 1 mark question also, you can also write the rule. Since we have used, what rule we have used, you can also mention it. Since log a to the power of x or something, here you write b is equal to x log a base b. Okay, you can mention the rule also. Okay, it will be impressive. Now, let's see the next one. Log 1 by 16 base 2. 16 will deduce into the factors of 2. 16 is 2 to the power of 4. Now, 16 is in the denominator part. Let me write it here. 2. 1 by 16, I can write it as 1 by 2 to the power of 4. Again, I can write this 2 to the power of 4. You can write it in the denotation of negative. If the power is below, if you are bringing it into the numerator part, there will be a minus. Now, here we can apply the rule of power. Minus 4 comes before. Minus 4 log 2 base 2. As we know that log a base a is 1. So, we can write minus 4 into 1 is simply minus 4. Okay. We will be deducing 16 into the power of 2. Now, let's see this one. The next one. Here, it is in the square root form. Let me write in the exponential form. Square root means 1 by 2 exponent. If it is cube root, raised to the power of 1 by 3. Now, here again rule of power. It comes front, log x base x. Now, this is completely 1. Half into 1 is just half. Okay. Now, here let's see the next problem. Log 0.01. Now, if you are taking, let me take here the rough part. 0.01, see here, I'll be writing in the form of a fraction 1 divided by 100, isn't it? That means 1 by 10 square. If I bring it to the top, 10 to the power of minus 2. That we'll do in the rough part and write it here. So, the decimal part I've written 10 to the power of minus 2 base 10. So, what am I doing in all these sums? I am bringing it to the same base. Like here, log 5, log 5, log 2, log 2, log x, log x. So that part will become 1. So, again rule formula, that is power rule of power, that is minus 2 comes front. So minus 2 log of 10 base 10 equals minus 2 into 1, that is minus 2. Now see here, the base is 2 by 3. I'll bring this into the form of 2 by 3. So 8 by 27 we can simply write as 2 by 3 whole cube. See here, 2 cube is 8, 3 cube is 27. So I've got it into the form of 2 by 3. So again, if you apply the law of power, that 3 comes before 3 log 2 by 3, 2 by 3. Same basis. So 3 log, so 3 into 1, that simply equals to 3. Okay. Now see here. This one, we haven't got this. This is plus. See here. This one, there's a property which we need to know. I'll tell you the property. See here. If a to the power of log, if n base a. So this will simply deduce to n. This is another property which only for this problem we are using it. Here see, if there is an exponent like this, the base raised to the power of log n base. Here you clearly observe that this a and this a are same, isn't it? The base of the logarithm as well as in the exponent the base, if they are same, then it will be simply deduced to n. Using this formula we'll do this, okay? And also we know that in the exponents a to the power of m plus 1, a to the power of m into a to the power of n, we know that laws of indices, the first one. So like that, what I'll do, this is in the exponents are added. So I'll write in the form of multiplication. So it comes to 2 to the power of log 3 base 2. Okay. Now 2 square is 4. Okay. 2 to the power of log 3 base 2. What I told, if the base and this value are same, then it will simply deduce to 3. So here it is multiplication. Simply comes to 3. I am using this formula. You have to mention it. Which property you are using. A to the power of log n base a is always equal to n. So simply the n part is 3. I've written 4 3s are 12. So likewise these will be coming for 1 mark questions. Okay, let's see the second problem in the exercise. Quickly copy down please. See here, write the following expression as log n and find the values. See here, there are 2 logs here. We have to bring it into a one expression with 1 log. Okay, log n we have to bring. So using the same properties, here we have to use the property of log. But yesterday what I have told you, the properties are both ways. So they can be deduced both ways. Here, so this power comes here, log 3 square and log 2 cube. I have applied the same thing. The formula log a to the power of x, if you take b or x here, x log a. Okay, so here both ways we can use it. So this is in this form, I have written in this form. Okay, now also the division formula, if there is minus and separated, they will become division part. So this comes to 9 minus log 8, isn't it? Now this is equal to log 9 by 8. So I've simply brought into 1 log n log formula. When there are 2 logs, I've brought it into 1 log. Now let's see another problem here. This is one problem. Now see here. There is addition. We have to apply the rule of multiplication. See here. And before applying, see all the 3 logs. If there are any numbers beside it, just bring it to the power form. Then you apply the division part. See here, log 10. This I'll be raising to the power 3 square log 2. Right here. Now we'll apply the multiplication formula. That means these both will become 10 into 3 square. Again log of 2. Right. Here it comes to log 3 square 9. 9 into 10 90 minus log 2. Let's apply the division rule. Okay. Log 90 by 2. This comes to log 45. We have brought it into 1 log, that is log n. Okay. quickly note down, children. Now we'll see the third sum. See here, the third one, evaluate each of the following in terms of x and y if given the x value is log 3 base 2 and the y value is log 5 base 2. That means we have to evaluate this in the form of x and y terms. Okay, this logarithms we have to bring it in the form of x and y, where x value is log 3 given and y value is log 5. The bases are common. Now let's see here. We will expand this. 15 we can write it as log 3 into 5. Okay, 3 5s are 15. Now if I apply the multiplication rule here, it will be separated into addition. Log 3 base 2 plus log 5 base 2. You can also mention the log. Okay, here log 3 base 2 is x, we know, and log 5 base 2 is y. So this form we got it as log x plus y. Now coming to this here, 7.5. See here, let this be the rough part. Okay, 7.5. 7.5 can be written as 75 by 10. If you cancel it here, 5 ones, 5 ones are 5 and 2 here, 5 5s are 5 2s are. It comes to 15 by 2. Okay, I'll write that. This comes to log 15 by 2 again base 2. If it is division, then it will be separated to subtraction. Okay, now this comes to log 15 base 2 minus log 2 base 2. Okay, again 15 we have to do in this way. We will split it. Okay, 3 into 5, 15. Again log 2 base 2. Here 3 5, and I'll use the multiplication law. Log 3 plus log 5 minus log 2 base 2, all are having common basis. Now log 3 is x. Log 3 value is x here. Log 5 is y. And log 2 base 2 is 1, we know. So this expression has been reduced to xy form in terms of x and y. Now let's see another problem in the same bit. Now we have 6 7 5 0. We will write the factors first. We'll find out the factors in the rough column. Now the factors of 6. So let's start with the simple one, that is 2. 2 3s are 6. 2 3s are 6. 1 2 7s are 14. 1 7. Okay. This will not go with 2. Let me try with 3. Will it go with 3 or not? Let's check the sum of the digits. 12. 12 plus 3 15. 15 plus 3 18. So it goes with 3. 3 1s are 3 1s are. 3 2s are 6. 3 5s are 15. Again, let me check, will it go with 3 or not? I'll sum the digits. 5 plus 2 7. 8 9. So it goes with 3. So 3 3s are 9. 2. So 3 7s are 21. 5s are. Again, it will go with 3 or not? 12 plus 3 15. So 3. 3 1s are 3. 3 2s are 6. 3 5s are 15. Again, we'll check for 3. 7 plus 1 8. So 8 will not go in 3 table. So let's see the next prime, that is 5. 5 2s are 10. 5 5s are 25. So 5 5s 25. 5 1s. So 6 7 5 0. We got all the factors. Now let's write these factors here. 2 into 3, how many? 1 2 3. 3 raised to the power 3 and 5 raised to the power 3. Okay. Simply I got it into the factorization process. Then here, if you apply the rule of multiplication, this will be split. Okay. Log 2 base 2 plus log 3 cube base 2 plus log 5 cube base 3. Okay. Base 2, sorry. Okay. All bases are equal. Now log 2 base 2 is 1. Okay. This we can bring it forward. 3 log 3 base 2. 3 log 5 base 2. Okay, this is 2. Now here, these are x and y. So 1 plus 3x plus 3y. So we have brought into the xy terms. So pause the video and quickly note down. Let's see next the fourth problem. Okay. Expand the following: log 128 by 625 and log under root of x cube by y square. Here we have to expand this logarithm. Okay. Before that we will find the factors here. We know 128 is 2 raised to the power 7. If you factorize, you will get with 2, 2 64s, 2 32s, 2 16s, 2 8s, 2 4s, 2 twice, 2 ones, 1, 2, 3, 4, 5, 6, 7. So 2 raised to the power of 7. Here the bases are not given. That means we have to assume them as the common logarithms base 10. Okay. Log 128 means 2 to the power of 7 and 625 is 25 square, or we can say that it is 5 raised to the power of 4. Oh, just find out the factors and write down. Okay. Now here this is division part, so it will be separated to difference 2 to the power of 7 minus log 5 to the power of 4. Okay. Now we'll apply the power so that the terms in the power form will be coming to the right side. Log 7 log 2 minus 4 log 5. So this is the answer. Here the question is expand the following. We are expanding it. Whereas what we have done in the second one, we have brought it, the expression, into 1 log n. Now see here this one. Here the square root, we'll write it in the exponential form. Here log x cube by y square raised to the power of 1 by 2. It is square root, so 1 by 2. If it is cube root, 1 by 3. Now we'll separate it again. X, 3 into 1 by 2, it comes to 3 by 2. Power here 2 and 2 will cancel, just y. Okay, 2 by 2 is 1. Now we'll apply here the logarithm property. Okay, log x 3 by 2, because it is division, and bring it into the minus form. Okay. Now the power rule, just bring the power to this side. 3 by 2 log x minus log y. I have expanded the 1 log into 2 logs. Okay. Quickly note it down. Let's see the next problem. See here. If log x plus y by 3 is equal to half into log x plus log y, then find the value of, we have to prove, we have to find this value of, here you see there is no logarithm here. Now we have to deduce into x and y form. Okay. Now let's take this expression. Here there are 2 logs, we'll bring it into 1 log. Okay. Here log x plus y by 3. So already this side we can take it as half log xy simply. Okay, here addition, so we have brought it into multiplication. That means I have brought it into 1 log form. Now here this is log x plus y by 3. Now here this part you can bring it to the exponent. Okay, xy raised to the power of half. That means just square root. Okay, square root of xy. Here log x plus y, both are logs, you can remove the log. Now just x plus y by 3 equal to square root of xy. Now cross multiply, x plus y equal to 3 square root of xy. Squaring on both sides. Squaring on both sides. Okay. Here we get x plus y whole square, the algebraic identity, and here square. That means 9xy. 3 square 9 and square goes off, you get 9xy. Here we'll expand this identity, x square y square plus 2xy equals to 9xy. Let's bring 2xy to the other side and write it on the top weight. Minus 2xy. So this comes 9xy minus 2xy, 7xy. we'll write it here. Okay, x square plus y square is equal to 7xy. 9xy minus 2xy. Now bring this xy part to the LHS. Bring it to the LHS part. So simply x will be here. Now we will dissolve the LCM. We know how to find the LCM. Now we will dissolve the LCM. So it comes to x square by xy here, y square by xy here. That comes to 7. So 1x will be cancelled, 1y will be cancelled. Now the remaining is x by y is y by x equals to 7. So the value of this equals to 7. So find the value of x by y plus y by x, that is equal to 7. So like these problems will be coming for the 4 marks. Now quickly write down, pause the video and write down. Now we'll see the next problem. Now the 7th one, if 2.3 raised to the power of x, 0.23 raised to the power of y equals 1000. Then find the value of 1 by x, 1 by y. Now these three are equals. Okay. First let me take one. This equality. 2.3 whole to the power of x equal to 1000. Okay. Now 1000 I can write it as 10 cube. Okay. If I want to bring the exponent here to this side, if I want to bring this exponent to the other side, it will be raised to 1 by x. So like 2.3 is 3 raised by x. The exponent to the other side, it becomes 1 by xth part. Okay. Let this be equation 1 or some for substitution we'll take. Now we'll take this equality. Okay. The y part is equal to 1000. So 0.23 is equal to 10 cube. Okay. Now I'll bring the decimal part to this 2.3. That means it comes to 10, isn't it? 10 cube. Here 2 power y I've written. Okay. Now 2.3 in place of 2.3 I'll replace 10 raised to the power of 3 by x by 10. Again raised to the power. This y is there, children. See here. 10 cube. Okay. Now we'll see here. Here just 10 is there. 2.3. In place of 2.3 I have kept 10 raised to the power of 3 by 5. Now here if you write 10 raised to 3y by x, 3y by x by again 10 to the power of y. And this comes to 10 cube. Here we will apply this exponents because division is there. So the exponents becomes difference minus y equal to 10 cube. The bases are equal. We can equate the exponents. 3y by x minus y equals to 3. Okay. Let me take the LCM here. X 3y minus xy equal to 3. I'll cross multiply this. Okay. No need of cross multiplying. See here. 3y by x. Here y is common. Let me take y first. 3 minus x by x. See y I have taken common. Here x is left over by x equal to 3. Okay. Now this y it is multiplied. So I'll send it to that part. It becomes division. 3 minus x by x equal to 3 by y. Now what we have to prove? 1 by x by 1 by y is equal to, we have to prove. Now I'll dissolve this LCM. 3 by x, 3 by x minus x by x. So LCM I have split it, okay, by 3 by y. The y term I'll bring it here. X by x is simply 1. Okay, y term 3 by x minus 3 by y. Here minus 1 goes to the other side. Okay, now let's take 3 common here. So 1 by x, 1 by y. Taken 3 common here. Okay, this is what we want here. Okay, this 3 I'll send it to the other side. 1 by x, 1 by y. Multiplication 3 here I've brought it to the other side. So this is 1 by x by 1 by y is equal to 1 by 3. So we have to find the value of this using this formula, and we have applied the log. So this comes for 4 marks. Quickly pause the video and note down, and let's see the next one. 8th problem. Problem 2 raised to the power of x plus 1, 3 raised to the power of 1 minus x. Then find the value of x. We have to find just the value of x. Here, let's see here. This is an exponent, 2 raised to the power of addition. So I'll write it in the form of multiplication. Okay. To the power of 1 by 3. See here, the exponent. There is plus in the exponent, so we have divided, multiplied. Here there is minus, we have divided. Okay, now here let's apply log both sides. Log 2x into 2 is equal to log of 3 to the power of x. Again, division, so we will separate it. Okay, this comes to log 2. So this is log 2. Multiplication I have separated into addition. Now this is log 3 minus log 3 to the power of x. Okay. Now here we will bring this powers to the other side. See, x log 2. We have used the power rule. Okay. Now this is log 2. Here log 3 minus x log 3. Okay. We will bring the x terms to one side and the constants to the other side. So here x log 2, this term I will bring it here, it becomes plus x log 3. Now log 3 this side, I will send this log 2 to the other side. The constants to one side. Okay, now x I will take common, log 2 plus log 3. If I take x common, we get log 2 plus log 3. Here log 3 minus log 2. Now x multiplied, so this part I will send it down. X is equal to log 3 minus log 2 by log 2 minus plus log 3 here. So the value of x is this. Also we can write it in form of 1 log, like log 3 by 2. Isn't it? Minus, no? So 3 by 2. This 3 into 3. So by log 3 3s are 9. Log 2 log 3. So 2 3s are log 6. So this is the final answer of x. So find the value of. Now this is log 2 rational or irrational? Justify. Now we'll prove this from the method of contradiction. Okay. Now is log 2 rational? Let me take log 2 as rational. Contradiction method will do. Let log 2, if there is no base given, take it as base 10. Okay. Common logarithm. Let it be x. This is our assumption. Okay. Let it be x is a rational number. Okay. And suppose this as rational number. Rational number. Now, from the formula of logarithm, here this is equal to x. That means if you write it in the exponential form, 2 is equal to 10 raised to the power of x. Isn't it? Here, see. And also, I told that we are assuming this as x. Log 2 base 10 is x. This x is a rational number. Rational number means, suppose I will tell this as p by q, where p and q are integers, right? And also an important condition that q must not be equal to 0. This is the condition of rational numbers. When I am telling this log 2 is a rational, so I have equated to p by q, where p, q are integers and q not equal to 0. Now if you take here, also if you apply here the same thing, 2 equal to 10 raised to the power of p by q. Okay. Now these two values are equal. Okay. Now let me deduce both sides. I will raise it to the qth power. Okay. 2 to the power of q is equal to 10 p by q. I am raising it to qth power. Both sides. Okay. Now this becomes 2 raised to the power of q. Here q cancel, 10 to the power of p. Here we got 2 to the power of q is equal to 10 to the power of p. where P and Q are what? Our integers, and Q must not be equal to 0. If they must be equal to 0, in this case, only one possibility is there for them to be equal. What is that possibility? Only when P equal to 0 or Q equal to 0, only then these two values will be equal to 0. Okay, P, Q values, if they are 0 only, our statement will be true. But we know that the Q value strictly is not equal to 0. As we have told that this is a rational number, so our Q value must not be equal to 0. If Q value, here we got that Q value must be 0, but the Q value is not equal to 0. So here a contradiction arises. There is a contradiction. So if a contradiction comes, what our assumption we have taken is false. There is a contradiction. So our assumption is false. Our assumption is false. Okay. So what is our assumption? That this is a rational number. It is false means what is true? Therefore, log 2 is irrational. So this is the method of contradiction. Okay. So we have proved that log 2 is irrational and we have justified the proof. Okay. With this, we have come to an end to the exercise. I have solved maximum 80% of the exercise. The rest 20% you take it for your homework. Practice well and let's meet in our next class. Thank you all.